It's too much. Hello, everyone.
Good morning.
Hello, Leroy. I've read your flashbulb memory of 9/11. That's amazing. The details that you remember.
Yeah, it's very vivid, like it just happened.
Yeah, I remember because, I'm in New Jersey, but I'm very close to the George Washington Bridge. We saw the smoke, but not that much. What we experienced for a whole week was the smell, the burnt smell. And that's one of my sort of sensory memories that is very strong. Yeah. Does anybody else remember anything from 9/11? Were you guys even born then? Karen, Becca, Diamond, Ari?
I don't remember anything. I was still really young.
No, I can see. You guys
Yeah.
were 1 year old.
Yeah. I was also in Israel at the time, so
Ah, yeah, of course then. Mm, interesting. I don't remember. I just remember my parents told my dad was late to work, so he missed it. Okay, so this is more of uh, a story of your family, less a story of your own. Okay, well, if you guys have time, read um, Leroy's blog. And that's really very interesting. I mean, he was lucky in the sense that he overslept that day. He didn't go to work to his uh, wireless store, which was on Manhattan. That's, man, talk about fortune. I mean, personal fortune as opposed to nation's misery. Mm. Now, remember that the blogs are open for everybody to enjoy. And I said it many times before, and I will continue to say that if you guys have time, read Leroy's posts. They're really excellent. Thank you, Leroy. I mean, it makes my day when I read them on Monday. And other people are doing well too. So I'm happy to say, although, let me just check. I have been trying to get 4 people who haven't contributed anything to do so, and I am happy to report that 2 out of 4 started posting. Yay! That is good. I'm just gonna check and see. Yes. Uh-huh. Beautiful. One of these people is with us today. Fantastic. Okay, great. So, a couple of logistics. The first one is that there will be a another colloquium on Thursday. Let me show you the announcement for that. Okay, let's go to announcements. Okay, so this is the announcement. The link for this colloquium, which is going to be on applying to grad school, is different from the one from 2 weeks ago, but the the link that is provided here as well as in the weekly schedule is the new one. So if you want to attend, remember, please register. It's all automatic. They just get your name and your email address, and then you will see the Zoom link on Thursday. Again, this is something that you could apply for your participation points. And if you are considering going to, I assume, a master's program is the appropriate step, this is going to be very useful. All three of my colleagues who are holding this colloquium, Melanji Danton, Jennifer Wagner, and Leora Yetnikov, are all relatively, well, I wouldn't say new, but they've been with us for 6 years, and Leora only for 4. So they are very close to what it means to be in grad school. So they're going to be excellent people for you to listen to and then ask questions. So please do so. Again, this is this coming Thursday, October 29th, during club hour. I think it's 3:30, not 2:30 to, well, potentially to 4:30, but you don't have to stay all of the time. If you need to go, that's not a problem. So please do. An easy 1 point, useful. All right. Next is another logistics issue. Okay, let's make it large. Okay, so this is it. If not counting this week, we have 3.5 weeks in November, 1 full week in December, and 1 last class on December 8th, which means that we are 2/3 into the class. So next week, yay, we're gonna do language as well as week after. So the first 2 weeks of November are about linguistics. Yes, I'll have to torture you. I'm just kidding, but language actually is the quintessential cognitive facility that we have. So I have no qualms spending 2 weeks on that, although the textbook only gives us 1 chapter. So for week 11, next week is week 10, the week after is week 11, language acquisition. I'm going to give you a separate reading because there's nothing in the text. Well, there is a little thing in the textbook, but that's not enough. So there will be, as usual, a quiz that has opened already for next week. Remember, language is difficult, so I urge you to spend a bit more time reading the chapter, doing the stop and think questions and stuff like that. Instead of quiz 9, we will have this language acquisition theme. So we will watch a 55-minute documentary on the most famous feral child case, Jeannie. And then, so that's 55 minutes, and our class is almost 2 hours. You'll get the rest of that. So that's going to be on the 12th. The rest of the Thursday to write your quiz, which will be a little bit different from our usual quizzes because you'll have a couple of essay questions. So there will be no quiz due on Monday, the 9th, but the actual quiz will be done in class on the 12th. So please make sure, I'll repeat that on Thursday as well, but talk to your partner and just make sure that they are with us on the 12th. It is possible to find this documentary online, not always available. It's funny. I have DVDs, but they all are in the lab, so I don't really want to go. So we'll do it online. And then we will have 2 more chapters before Thanksgiving. Chapter 10, which is in concepts and knowledge. Interesting. And then we will do the first half of chapter 11 on problem solving. That is Tuesday before Thanksgiving, and we will finish that. Now, because we're losing a Thursday, we will sort of push the second session into December 1st, and we will finish chapters 11 and 12. with the last quiz due on November 30th. So over Thanksgiving, but you know, you guys are used to doing that. Note that your lab 2 report is due this Thursday. If you have questions, burning questions, today is the day to ask them. Now we will have a slightly different, better, I should say, rubric. So that's what I'm going to show you next. What happened to my rubric? Okay, let's double check. Oh, it is here. Okay. Why isn't it shown? Oh, okay, maybe it's further down. Oh, there it is. Okay, good. All right, so let's make it larger. Can everybody see it? Yes, okay, good. Thank you, Jeffrey. So I reformatted it a little bit so that I remember that this is the one to use. So it's the same 50 points. I just changed a couple of little things. For example, for the introduction, I added a point that you have to have minimum 3 paragraphs. More is fine. Okay. What else? And in the discussion, I sort of glued together implications and limitations so that you don't have to write separate paragraphs for each of these points. Okay, so these are the only 2 changes on the first page, which is content. Page 2, so here in 1 it said manuscript header, but it meant there should be no manuscript header. So I changed that to make sure that this is not ambiguous. What else? Looking through. I got rid of the tables because you guys don't have any tables, so there is no table. I gave everybody a point for that in lab 1, obviously, because I forgot to take it out. And I changed the references a little bit. I had like one point that sort of glued a bunch of things together. Now you have hanging indent, alphabetized authors' names with a bunch of other things as one point, and journal name, volume pages as another point. I think everything else stayed the same. Yeah. So 23 points for content, 27 points for APA style. Of course, it is posted for you on the Finding 5 section of the Blackboard. I think I emailed it to you guys as well. So if you didn't get it from the Blackboard. So my advice is before you're ready to submit, the person who will be submitting should go through this rubric and grade yourselves. So once some of them are a bit more difficult for you to assess, like 25 through 27, but judging from your lab 1 report, very few people had any problems with that because we have a structure that we discussed. So at this point, you should not be, so probably the most difficult one is going to be E, the results, because you have to have statistical symbols. You have to have inferential test results. Remember, paired samples t-test is the required one. If you want 5 extra points, then you have to go beyond that, following the research article. Maybe on Thursday, although it's going to be already too late for this lab report, but it will be okay for lab 3. Maybe I'll spend time showing you if you're still struggling with how to create a figure in Excel, but somebody has to remind me. If it's not on my mind, I may not think about it. Yeah, and remember that your t-test result should be written as a statement. That is, the way it is in the APA book and then explained in words. Right. Does anybody have any additional questions about the rubric or about Lab 2 report? Right, you could still ask me a question during the break, how usual, or email me if it is something that you haven't thought about, but it will pop up as you finish the lab report. I only posted one link. Hopefully, let's have a look. There will be no confusion this time. The first time, unfortunately, I didn't do it right because I posted in two places and that wasn't good. Let's see if we can do that. Where is it? Again. Okay, good. This is here. As usual, I'm checking to make sure that I get the components. Here we go. All right, so now if we go to, this is our Blackboard. It's a little small, but you don't need to see all the details. If you go to 3, finding fives, right, finding 5. Okay, and if you go to, so this is the rubric, it's right here. And I will use the same one for Lab 3. If you go to experiment 2, okay, I keep trying to place it at the top, but keeps sliding back. It doesn't matter. So here is the link. It says submission link. Okay, remember it's only one report from the two of you, not two. And it's due by 10 p.m. on Thursday. Right. Again, remember that you have the required file and then you have the extra credit file. This is just for the data analysis. With respect to everything else, it is the same report, except that the required one only only asks you to compare accuracy for animate versus accuracy for inanimate collapsed across the 3 trials. That gives us a t-test. If you want to do the extra credit analysis, then it becomes a 2x3, which is a much more well, it's not terribly complicated, but it's more complicated than the t-test. So, but the text is the same, right? It's only that you're going to have design that's different and the results that are different. Okay, fine, stop that. Again, last call. Any questions right now? Okay, good. So that's that. There is no final. There is no anything else. Will be done on December 8th. Because I will have your lab 3 reports on the 3rd. It's going to take me a week to finish. So presumably I'll have your grades over the weekend and we'll be done. And I'll never see you again. Just kidding. I may see you again in experimental if you decide to take Sci 330, experimental psychology, cognition, and perception. This course is a prerequisite for that lab. So if you like the material, and if you don't mind being pushed to write a lot, which is what you will have to do regardless of which lab class you're going to take, I strongly recommend that you take this course because you will be well prepared for it. Okay, so today,
I have a question.
okay, sure.
Just for the lab report, I'm wondering how many participants we have for this one. Is it 20?
Yes, we had 20 participants equally split between the 2 genders. So we had 10 men and 10 women.
Okay, thank you so much for clarifying.
Sure. Basically, your participants subsection is the same one as you had in Lab 1, unless I said something that it's not complete. So you can plagiarize from yourselves. However, the design and materials and procedure are different. Do not plagiarize them from your lab one. What you can self-plagiarize is the structure. If your structure was correct, you're fine. You just have to populate the template, right? Tasks, variables, examples, blah, blah, with what you did for experiment two. Okay, so you're plagiarizing, so to speak. I shouldn't use the word. You're reusing your lab one in the places where it was correct. Where it was incorrect, obviously you have to change. So because I will be grading this lab two already with an eye that you have done your first one. So you know a little bit. So I will be just a tiny little bit more strict. And for lab three, I will expect a perfect one because you will have had two by then. Okay. So unfortunately, we're done with memory. So we're moving to our next chapter, which is chapter 8. It's usually called visual imagery, but obviously imagery and visual imagery is the same thing. I mean, images are visual. It's an interesting chapter, especially if you are into this kind of stuff. So we will start a little bit with my usual historical introduction. I want to introduce to you yet again. We talked about this person before, Francis Galton, who was, it's a nice extra point if somebody could do that in the next few minutes. When did we talk about Galton before? In which chapter? Between 1 and 8. Now we will talk about him from his from the point of view of his research on imagery, which is different from what we discussed before. And then we'll spend most of our time discussing and talking about what's known today as the imagery debate. And the imagery debate is about the language of thought. Now, obviously, we all know that language of thought is obviously verbal, so to speak, right? Because we do talk to ourselves, we think sort of linguistically, but then there is a possibility that in addition to verbal language of thought, there is also visual, but not like perception, right? Because it is a language of thought, not a language of sensation and perception. So we'll talk about that and two approaches to this. One of them is represented by Stephen Koslin, and the other one is represented by Zen and Polishin. Then we'll talk about how imagery is related to perception. That is, are images like percepts, or are they different? And maybe just do a little bit of physiological neuroscientific evidence, not much, because as usual, we're not going to have enough time. So some of the things that we can do today, we'll do today in terms of little exercises, and other things will be postponed for Thursday when we will do hopefully more exercises. Okay, so that's our little introduction to what we're going to do. Okay, so like I said before, we studied usually verbal stimuli. Remember the name of the verbal learning paradigm that we spent a lot of time on just in the past 3 weeks. So we assume, right, that our mental code, that is the language of thought, is verbal. But then you start thinking about it and you say, okay, well, semantic memory, right? Facts that we know about life, or maybe our episodic memory, that is stuff from our personal experience, they don't always sort of fit that well into the verbal paradigm. I mean, when you when you think about taste, right? I mean, is that easy to describe it in words? Or what about pain? I mean, is pain that well described in words as well? So there are things that start making us think that the language of thought is more than just silent language. So if the knowledge is nonverbal, I mean, how is it represented in our mind or in our memory, right? And that's what this chapter is all about. So here's a little definition, and it's important for you to understand. These are the representations. So representations, right? Something that was presented, but then is represented in our mind. And these representations produce the experience of seeing, right? But in the absence of visual input. So again, I already mentioned that, and I'll keep saying that. Is a mental image similar, very similar, dissimilar to the actual percept? Now, remember that we talked many, many times before, and I will continue to push this line of thinking on you guys, is that the problem with cognitive psychology is that we can't really observe a lot of behavior directly. I mean, if somebody's thinking, how do we know that somebody's thinking? You can't. I mean, if you say, I'm going to observe the talking behavior, that's fine. Somebody's talking, you can actually record that, you can write down the words, and you can analyze the data, fine. But thinking, when it's not reflected and in talking, is invisible. And that is the problem for most of cognitive psychology, not just thinking. Even sensation and perception. I mean, there is a perceptive, right? And that is mental representation. And mental representation, in addition to information processing approach, are the two hallmarks of modern cognitive psychology. So image is the quintessential mental representation. I mean, what are its characteristics? How can we get to them? That you would say, don't we have neuroscience? Yes. So that will help us a little bit, but it still remains the problem. We have to infer what the properties are. We can't directly observe them. So that is the absence of the usual visual input, because if you're looking at something, a gorilla in the yard, you have a percept directly represented in your visual cortex. Now, if I tell you, well, close your eyes and think about a gorilla, how is that represented in your mind and then subsequently in your brain? So that is an important thing. So percept is there. I mean, remember distal and proximal stimuli distinction versus something that is not there. It's only the product of your mind. It's the product of your memory. It's the product of your experience, both semantic memory, what you know about gorillas, and perhaps if you have ever been to a zoo or you watched a documentary or something, or you read about gorillas, that's going to be your mental image versus, seeing gorilla in the zoo and having a percept. I hope that makes sense. Okay, so you will see a bunch of, again, terms that have been used not only in the textbook, but also in any other sources that you might have encountered. You will see something like mental pictures. That's fine. You can think of that as a synonym of images, mental images. There's a well-established line of research on mental maps, and we'll talk about those. And, we use them for all kinds of problem solving. Now, in particular, I'll mention later that you have an activity posted for you in the Blackboard about navigation. Now, if you think even 20 years ago, not even 20, maybe even 15 years ago, or even 10, before smartphones, if you were to drive somewhere, a place that you don't know about, you would use a map, right? You open up a map, either physical, usually physical map, right? And you would think about your route, how you would go, which highway you'll take, which exit. All of that was done by using maps. So people were well practiced in using maps. And then suddenly now we have Google Maps or whatever map app you have on your phone. And now you have to do is just listen and follow. But again, there could be circumstances when Google Maps is not going to do the best job there is. Once we were driving, my family and I, we were in Spain, and we were going from Barcelona to Tarragona, one of those places. And it kept telling us to go whatever, and we would go there, and finally took us to a culvert, this huge tube for water. It was the shortest way. Of course, not the best one for a car. So, you know, what do we do now when we don't have to learn how to navigate a map? Is that something that could be different in men and women? Are men supposedly better in navigation skills than women? So, there are practical implications of visual imagery. Okay, let's do a couple of exercises. For these exercises, actually, I want you to close your eyes, but don't fall asleep on me, right? And once you have the answer to the exercise, type in that answer in the chat. All right, so this is called imaged synthesis. All right, so let's do the first one. I'm reading from my cheat sheet so that I don't mess up the instructions. Okay, step one, imagine a capitalized letter D as in diamond. Okay, step two, lay this image down on its back so that the vertical side lies flat and the rounded side bulges upward. Step three, underneath it, position a capital letter J as in Jack, centered underneath the D and just touching the side that is lying flat. What have you produced? Yay! Very good, Leroy. Exactly, umbrella. All right, let's try number two. You guys should be faster, otherwise Leroy will get all the correct answers. All right, so exercise number two, step number one, imagine the number 7. Make the diagonal line into a vertical. Move the horizontal line down to the middle of the vertical line. Now rotate the figure 90 degrees to the left. What have you produced? No, not a V. Not a V. Anybody else? Shall I repeat? Imagine the number 7. Close your eyes because that's important. You have to focus on your mental imagery. Make the diagonal line into a vertical. Move the horizontal line down to the middle of the vertical line. So diamond, right? There is no horizontal line in V. Now rotate the figure 90 degrees to the left. Yes, now you're correct. It is a T. Beautiful. Okay, let's do one more and maybe that's enough. Okay, number 3. Imagine the letter B as in Boris. Rotate it 90 degrees to the left so that it's lying on its back. Put a triangle directly below it, having the same width and pointing down. Remove the horizontal line. What have you produced? Yes, Hummer, perfect. Yes, guys, perfect. All right, so there is something to be said about the way we manipulate images, right? Thank you. You are correct. It is the heart. Um, I've posted a couple of things for you to do of that type with image synthesis as your activity 9.1. In this case, I'm asking you to take 3 shapes and creatively rearrange them that they make something new, and take a snap of that and post to your blog with a little bit of an explanation. Okay, nice job, everybody. So where do we start with studying imagery? Well, did anybody remember by any chance when we talked about Francis Galton before, in connection with which topic? Uh, no. Uh, well, I will give you a little hint. Cue the recall. The word of that line of thought, let's put it this way, that Galton was involved in the 80s of the 19th century was something that started with P. P. All right, that's that's the name of that topic, and we talked about it. Can anybody guess a letter? I'm not going to hang you though. Karen, guess another letter in that word.
I'm not sure.
Well, what are the most frequent letters in English? No, it's not
Um,
priming. It's vowels, right? Vowels
A.
are the ones.
Yeah.
Which one?
A.
A. No,
E.
yes, there is
Okay.
an E here. Okay,
Isn't there a vowel in almost every word?
absolutely.
Yeah.
Except in a couple of languages. Um, no. As you can see, Diamond, there would have been 2 E's. Diamond, guess another letter. O. Okay. Uh-huh. So, well, that's maybe it. Maybe you'll guess now. Ah, I gave you more. Okay, can somebody finish the word? No. Oh, come on, guys. Oh, okay. Oh well. Does anybody remember what that is? Ah, okay. Well, maybe you'll look it up. So, in addition to phrenology, uh, Galton was also interested in using the method of introspection that I'm not going to give you a puzzle about, but phrenology comes from, our German um, psychology, right? The introspection. Wilhelm Wundt was the first psychologist in the sense that we ascribe to that word today. And Wundt asked his participants to introspect about objects. So a very typical sort of type of experimentation that Wundt did in his lab, although he also had some equipment, would be to show his participants an object like this and ask his participants to introspect, that is, to describe what they see. usually using adjectives, that is, words that characterize the object. So somebody would say white and flat and thin and rectangular and whatever, right? So using this method of introspection, and remember, again, cognitive psychology is introspective because you can't directly observe a lot of stuff. He would ask his participants to introspect or inspect images that he would give them as examples. Now, I don't want to do it today because I want to do it on Thursday. We will actually work through a short questionnaire that Galton actually invented. So that has been 150 years ago, and we can still use that. And then he would look at the way people would answer the questions in his questionnaire, and they would look very, very similar the way one would describe an actual digital stimulus, right? If somebody asks you to think about and imagine a tree, you will probably have the same characteristics as the actual tree if you were looking at it. However, what he found, in addition to the fact that people's images were very, very similar to the actual percepts, he found a lot of individual differences. So some of the people were very good at that. Well, good is not the right word, were very adept at this. They would have incredibly detailed and vivid descriptions. And other people were like, not sure. Now, of course, I gave you a kind of silly example, like trees. Well, but you can imagine, I'm not going to do that now because I don't want to spoil our Thursday little exercise. Imagine something more complex than a tree. Then the way you describe it would be very different if you have vivid imagination of visual imagery versus if you don't. So if you guys, how many of us are here? 9. You guys think about it for a second. Do you think that you are um, somebody who has vivid imagery, or somebody who, for this, of course, you need to think of something from your past, some kind of an event that could be described. And then close your eyes again and try to imagine that event the way it happened. And think, do you think that you see lots of details? See, in your mind's eye. Do you feel like the event has, auditory component or olfactory, that is smell and sounds, stuff like that? Or uh, you just completely abstract? Okay, good. Rebecca says, I do see vivid detail. Excellent. It's an interesting way, and we'll do this little questionnaire that will allow you to actually kind of run yourself through this. I mean, there's nothing wrong with either having very vivid imagery or having very sketchy one. It's just your individual differences. Okay. And something that we will keep in mind, because it will reappear for the imagery debate, is, well, perhaps it is not about imagery, but perhaps it is about your sort of verbal ability. I mean, if you were to, as opposed to, I mean, you may have an image, but then you have to describe it to us, to the experimenters. Maybe your description is poor, so to speak, and not so full of detail, not because you don't see it that, but because you are not producing the kind of descriptions that would make it more elaborate or something. So it is possible, if we're asking people to be sort of subjectively involved in describing the stuff using language, we're not getting to the imagery per se. That is critical for that language of thought debate. Okay, so we have differences in self-reported data, and that's a well-known finding in psychology. Okay, so think about it. We also, I mean, I don't know if you have heard about that. but there is this talk about the kind of learner you are. Are you a visual learner? Are you an auditory learner? Are you a kinesthetic learner? Now, of course, if you would like to do that for your participation point in your blog, that's fine. But I have to tell you that unfortunately, there is not much truth in that because we are all of the above. We are all learners that learn visually, auditorily, kinesthetically, blah, 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 depending on the task. So there is no such thing as saying, oh, I can only learn visually and show me the images and videos and whatever, and then I'll learn. No, because if the task is such that it lends itself to the visual representation, then everybody will be learning better from the visual stuff. We talked about implicit memory, procedural memory, in particular when we were looking at long-term memory. So if somebody wants to teach a child how to ride a bike or, tie the laces on the shoes, using language is almost useful, not only useless, not only useless, but actually detrimental. You have to show. So this whole approach is one of those myths that we as cognitive psychologists try to dismantle all of the time. But teachers continue to say, oh, I have students who are visual learners and students who are kinesthetic learners. I have to give them something. Again, it's a myth. But if you would like to explore this more, that's something interesting. So what Galton found in his research with vividness questionnaire, which we will do on Thursday, is about 10% of people reported no visual images at all. Now you would say, well, how can it be? That's interesting. So we'll try it on Thursday and see if we get anybody who thinks that he or she does not have vivid imagery, which is again fine. It's just an individual difference. Okay, so that's sort of the prequel, so to speak, to the modern cognitive psychology. Again, remember 1950s, that's when Noam Chomsky became active in linguistics, and that's when a lot of people doing sort of computer, it wasn't really computer then yet, but sort of information processing approaches, Donald Broadbent, that's attention, people who started doing the model of memory, Atkinson and Shiffrin, in 1960s, about this time, a little later in 1970s. So how do we answer this question? Does the language of thought have more than verbal code? Well, obviously, we have to have an experimental evidence. Remember, when we talked about memory, I said that there are two lines of evidence that we use in cognitive psychology to give us more information about a particular theory that we want to endorse. One of them is experimental. So think about the serial position effect. And the serial position effect gives us the difference and recall at the ends of the list. Primacy obviously is this way. Primacy is the stuff that has already been pushed into the long-term memory, and recency is the stuff that's sort of hanging out in the working memory, giving us the distinction between the two. We also have neuropsychological evidence, right? We have amnesic patients like HM. You guys, quite a few of you uh, took me on answering a question about Henry Mlassen. For amnesic patients, we have this double dissociation approach where we're looking for somebody whose short-term memory or working memory is not perfect, but long-term memory is much better, a rare case. Or the other way around, somebody whose short-term memory, working memory is okay. It's not perfect. You are a patient anyway, and you have no really long-term memory. So that gives us the idea that memory is not a unitary box, so to speak, but it has different stores. The same here. If we want to address the issue of how imagery works, hey, we need to think about experiments. So we'll create, like I did with the little exercises with you guys, we'll create something, some instructions that will allow our participants to be engaged with the imagery, right? So we'll ask them to do something with these images. Okay. Now, again, another hallmark of cognitive psychology, and that's why I've been asking you to read all these articles for each chapter and articles for your lab reports. Cognitive psychology is done with reaction time measures. Accuracy too, less so. We are doing more accuracy perhaps in this class because it's easier. If you want to move on to reaction time data, like I said, come to 330, experimental psychology, cognition, and perception. A lot of that will be reaction time data. So the idea is that cognitive processes, that is you manipulating these images, right, take time. They, of course, take very little time because we are perfect cognitive machines, so to speak, but they do take time and we can measure this time. Remember Donders, perhaps from chapter 1? Franciscus Donders from Holland, who was the first person to tell us that the reaction time in simple task, all right, if you see the yellow happy face, raise your right hand. If you see yellow and red, then yellow is right, the red one is left. That's a selection task, and that takes time than the simple choice. That's the basic foundation of cognitive psychology. So 1970s, we do the same with mental imagery. So how do we compare pictures versus verbal descriptions? So again, nobody challenges the fact that the language of thought is, if not all, but highly verbal. That is, we talk to ourselves when we think. But do we actually have anything else? So let's perhaps do another little exercise. If somebody's willing to play along with me. We need to describe an object in words. So my choice of an object would be a cat. Does anybody among you guys have a cat as a pet? Okay, Parker says yes. Jeffrey, your brother does. Okay. Jeffrey, would you, or Parker, used to, I see. Parker, has your mic, does it work today? Still not. Your mic is broken. Okay. Jeffrey, what about your mic? Does it work?
Yeah, it works.
Fantastic. Jeffrey, would you mind describing a cat in words?
Uh, Fluffy, quiet, curious. Wait, do I just keep going?
Yeah, keep going. But think about it, Jeffrey, for a second. Imagine that you are describing this animal to somebody who has never seen a cat before. Now, what are you saying? Will that be helpful for that person to imagine this animal?
And I only use words?
Yes, you can only use
Okay.
words.
Fluffy, furry,
Uh-huh.
small.
You can actually have full sentences, Jeffrey. You're not restricted to using just
Oh,
single.
I thought you wanted me to only use
No. I would like you to use the full sentences.
a cat is small
Okay.
and has a lot of fur. It's very fluffy. It has a tail.
Uh-huh.
It has a small face,
Uh-huh.
pointy ears.
Uh-huh.
Uh, it's very curious to nature,
Uh-huh.
and it's very quiet.
Okay, good. All right. Okay, good. Thank you,
Yeah.
Jeffrey. So now imagine that I am a sketch artist, right? Not that I'm very good at that, but we'll try. So first thing that Jeffrey said was fluffy. So I'm just gonna sort of make fluffy stuff. All right. That's kind of fluffy. You guys have your imagination. Now, then Jeffrey said it has a tail. So, okay, I don't know what this tail looks like, but let's assume that this is a tail. The next thing that Jeffrey said was a small face. Okay, so it's a small face. And then pointy ears, right? Okay.
And
And
4 legs.
no, no, you didn't say that. That's what you said. Okay.
Yeah, I just realized.
So when you describe, and that's perfect, Jeffrey, that's precisely what I wanted. Yes, you were describing the cat because you know that you know what the cat is, right? But I gave you a hint saying that, hey, it's our alien or uh, somebody who lives in, I don't know, island that does not have any cats. So now, yes, we need legs or paws. We need whiskers, perhaps, right? We need all kinds of other stuff. Spitting image of this cat, right? So the verbal depiction is very different from um, visual depiction. Now, Jeffrey was actually better than some other attempts because Jeffrey at least mentioned the face. I can't tell you how many times I heard Fluffy and Whiskers. So you get Fluffy and you get Whiskers, and that's your cat. Huh. So very, very different, right? Let's get rid of this so it doesn't interfere. So when you sketch an object, you need very different information. You don't need to know that the cat is curious and quiet and perhaps small is okay, because you can't depict that. But when you describe, right, what information is included depends on the mode of representation. If you're going to describe it verbally, you will say things like curious and small and quiet. And if you are actually trying to create a mental image of that animal, you need, you know, mundane things like whiskers and nose and paws and whatnot, right? And that's what this debate is about, so to speak. It's my little demonstration between Stephen Coslin, who is the proponent of mental imagery as such, saying that, yes, language of thought is mostly verbal, but there is a large component that is visual. And Zenon Palishin, who is a proponent of verbal stuff, and he uses the word propositions. And we talked about propositions when we talked about long-term memory. I know of Coslin only by reading his stuff, but I was actually a postdoc at the Rutgers University Center for Cognitive Science, and Zenon Palishin is there. So I actually spent quite a lot of time going to Palishin's talks and just talking to him. He's a philosopher. He's a very interesting guy. I hope he probably is retired by now. So the issue is the format. That's not the content, right? The content is there regardless, but whether it's all verbal or verbal and visual, because again, these are not percepts; these are mental representations. Come on, go on. Oops, here we go. Okay, so here is the a quick illustration that I will come back in a few moments. So what you see on the left of the screen is Coslin's stuff. These are depictions, images, mental representations. So usually for these early 1970s experiments, they used objects that were sort of vertical. Okay, so here's a clock tower of sorts, or a flower, right? Vertical because you can actually sort of move up and down, or horizontal No, you're going to go from left to right. The example that I will use in a minute is this speedboat. Okay. So what you can see is a porthole in the middle. All right. That's the porthole. And then you have the anchor on the right, and you have the motor on the left. So you can ask people to do various things by directing their attention to these components of the image. Now, what you see on the right is Polition's idea. So, hey, why do we care about, and this is the representation of the boat, speedboat. So this one. So now this one is represented as a set of propositions. Okay. So if you think of that as nodes, we'll come back to this idea when we study semantic networks in chapter 10 in 2 weeks from now, just before Thanksgiving. You'll see that these are called nodes. Okay, so there's a rear deck, and then there's a cabin. Okay, and these are nodes, and there's front deck. Okay, and then there are links, right? Links between the nodes. So here's one. It's all here, but I'm just telling you. And then we have more nodes that underneath, right? So there's a windshield, and there's a porthole, and there are anchor. There is an anchor, and then there is a motor, right? So one could say that this representation on the left is exactly the same one as the representation on the right. Again, I'll come back to this idea. I just wanted to illustrate the fundamental difference between the two approaches, and that's why it's known as the imagery debate. So do you have a mental representation like the boat on the left, or do you have a representation like the sort of propositions, a set of propositions on the right? And here they are. Again, these photos are from about 15 years ago. So you Stephen Kozlan and Zenon Polishin. Like I told you, I listened to a lot of talks and seminars by Zenon. Stephen is an incredibly powerful talker. So if you guys have time, Google him and listen to something. Again, I have to say that, after all these years, 40 years of research, the debate is still on. The probable conclusion, so the probable implications are that yes, Kozlan is right. There's both verbal and visual mental representations. But I would say that there's more people who believe that Kozlan's approach is more viable than the one taken by Polishin. Polishin is actually Polish. That's why his name is spelled in such a funny way. Okay, so we just did this little exercise. That's from Stephen's early work. It's what is the mental image of a cat? And Jeffrey did a beautiful job telling us that cat is curious. But Jeffrey also did a good job by telling us that there is a head and there are pointy ears. Claws would be important, right? So the mental image of a cat is quite different from how we would represent it verbally. So that's when we're thinking of cats, we are trying to imagine that we don't think about its characteristics beyond what's there in terms of body, head, fur, tail, paws, so on. Okay, let's do this other little exercise. You guys know who Snoopy the dog is? Okay, Leroy does. Anybody else? Snoopy, come home. Has anybody watched that cartoon? Okay, then we can't do that if Leroy is the only one who knows what Snoopy the dog looks like. But what about Mickey Mouse? You guys know Mickey Mouse? Okay, then here's my question for you. What? Okay, good. What is the shape of Mickey Mouse's ears? Excellent. Circles, yes, round, perfect. What is darker green, spinach or lettuce? Yes, perfect. Um, let's do another one. Which hand does the Statue of Liberty hold the torch? Excellent. Now, I'm asking you to introspect for a minute. How did you perform these three little tasks? Do you think, well, obviously I'm asking you because I would like to hear, yes. Do you think that you sort of imagined? Yes, you imagined Mickey Mouse and his ears, and you thought about spinach next to lettuce, and maybe you imagine, Statue of Liberty in a harbor. Did you think that you inspected those mental images to answer these questions? I would hope that the answer is yes, because otherwise, how else would you have done that? Okay, so here is what, and then we'll take a break. Here is what Coslin proposed. He said, okay, if we can have images in our mind, then we can do things with them. So I'm going to focus on the speedboat, and I'm asking you to memorize it. Okay, look at the image carefully again. All right. Okay, now I'm going to take it away. So let's go back, I guess. Okay, so now close your eyes and imagine that speedboat. Now I want you to focus on the porthole. Okay, imagine that you have a dot there. So place a dot. And now I'm asking you to take this dot and move it all the way to the anchor. And the moment you do that, sort of raise your hand or tap on your desk or do something. Okay. Now, again, go back to the porthole in the middle, place your dot there. Now move the dot to the motor. And as soon as you get to the motor, either raise your hand or tap. Excellent. I hope you guys are doing that. Now I want you to focus on the motor and move the dot to the anchor. Again, raise your hand or tap or do something. And here's the question. Do you think that the first two reaction times, they're short, right? They're milliseconds, but still, do you think the first two reaction times, moving from porthole to the anchor and from porthole to the motor, are different from the reaction time of moving from motor to the anchor in your subjective experience? No. Okay. Does anybody else have? Okay, Leroy says from motor to anchor was longer. Well, that's the idea. Diamond, that's okay. Maybe you are the proponent of Polition's approach. So the idea was that, I forgot where it was. Well, it wasn't a very elaborate, image, but that's okay. The idea here is that the reaction times are like a measuring tape. So if you are moving, so to speak, now remember these images, these are not actual objects. You're not looking at it. If the mental images are manipulated the same way as the actual images, now you're looking at this boat. So the idea is, now if we were to ask you to draw, let's say, I'm going to do that, right? So here's your dot, and now you have to move it to the anchor. All right, here's the dot, and I have to move it to the motor. Okay, whatever, 200 milliseconds. Now here's your dot, and you have to move it this way, right? This is twice the distance, so it's going to be twice as long, and that's what Leroy suggested. And Diamond said for her it was the same. Okay, so that's the idea. As long as you understand that we are measuring, we don't use the word scanning or anything like that. People do that spontaneously. But don't you think you could do the same with this image? So here's your let's say porthole. Okay, it's here, and somebody says, okay, now move it to anchor. So that's how you're gonna go. All right, that takes time, don't you think so? Actually, good. Leroy says eyes were moving. Perfect. That's what we do. People who do eye tracking. Now imagine that you're moving from here. So let's say you're on propeller and you have to go to the anchor. You're going to go 1, 2, 3, 4, 5. Okay. 3 versus 5. You're going to get the same results. And that's why there is a debate. How there was a debate. Because it looks like you could make, you could find longer reaction time even in verbal propositions. So it could be a confound. It doesn't really, this kind of approach doesn't distinguish the two that clearly. Okay, we'll do that next. So it's 11:17. Let's take a break until what? 11:23. Okay, break until 11:23. Okay.
Hi, Professor.
Hi, Isaac.
I asked a question like last Thursday about like the implications and what we were supposed to do. Because I was confused because I got like 0 on mine.
You were not here in the beginning of the class, Isaac. So I introduced the new rubric. Now let me show you what it is. Okay. Can you see it, Isaac?
Yeah.
Okay, if you look now at F, you can see that implications and limitations are now one paragraph, and future directions is another. Okay, so you could talk about limitation, and that's going to be enough, more or less. And then you would have to say something about whether this, in this case, animacy, right? Whether this has any kind of potential future directions. I mean, could you push this idea of animacy even further?
Right. So wait, so I don't even have to put implications in?
Yes, because now it's a single paragraph. If you select talk about limitations, that you will fulfill that point number 21.
So the first thing says the impact of the findings, especially with regard to a current issue or real world problem. I don't have.
Yeah, that is very similar to 22. That's why I'm putting them sort of into separate components. So if you could say, you have to think about it. I mean, we talked about the evolutionary benefit of animacy, but is there a way that you could think of how that could be used in education, in law, in, I don't know, anything that would be a real world problem?
Okay, so maybe I just have a direct. So now I'm asking, like, if I show you the last paper and ask why it got a 0.
We could do that, but why would you waste your time on something that is already done? Why don't you spend time doing it right
Because
now?
I finished the other paper, and
what you need to do, Isaac, is to learn from the research article. Why don't you open Nair and et al?
I've read plenty of research articles.
No,
And
I'm asking you about this particular
paper
one.
very well. But I'm just wondering, like, why I got a 0 on that one.
Okay, I'll look at it, but
Because I don't like spending like hours and hours and hours doing something and just getting and flunking every single thing that we do.
okay, I'll look at it and I'll get back to you on Thursday. How's
Yeah,
that? Or
that's
you want it earlier than that?
what?
When if I can get back to you on Thursday, is that too late for you?
I mean, it is because you're saying now, but all of a sudden you're gonna say, oh, you didn't put the implications in because it says it here. You're telling me this now, but it says on the rubric that I am supposed to put it in. So I know.
Okay, so then I'll try to do it tomorrow. How's that? I'll tell you exactly why you got a 0 on that paragraph.
Thank you.
Okay,
right.
You're welcome. Okay, so let's move on to the next step in Kozlin's research. And I told you that I'm focusing on Kozlin because his ideas are more sort of prevalent in the field. So in this well-known experiment, he asked his participants to memorize a fictitious map. So here's the map. It's also in the textbook. There we have 7 objects, actually maybe even 8, right? So we have a hut, a well, a tree, a pond. I guess that's a beach, right? Something like that. An island, forest maybe, and what, a palm tree or something like that. So now you can imagine, so people are given whatever time they need to memorize this map. It's a little bit more complex than the speedboat that we just played with. And before the experiment was initiated, they were asked to draw the map from the memory. So only when people were completely comfortable by, you don't have to draw perfectly, but as long as they could draw all these objects where they are, then they would progress to the experiment. And the experiment went just like what we did with the speedboat. So they would be asked to, let me get rid of this. They would be asked to, maybe we'll do a different color for a change, to position a dot, let's say at the well. Okay, so here's the dot. Again, they're doing it with the eyes closed. This is mental imagery. And they're told to push a button because they were doing it with the button box when they would get to, let's say, the pond. So there you are, click the button. And they would do all kinds of manipulations. You can imagine the next one is click the button when your dot gets to the forest, or when your dot gets to the palm tree, or when your dot gets to the hut. So if you are doing it the way I just did it by drawing, the predictions are simple, that this reaction time data, right, between the well and the hut is going to be the fastest. right? And the one between the well and the palm tree is going to be the longest, just because these are the distances on the map. So this is what Koslin's depiction approach would predict. And that's, of course, I'm telling you this because that's precisely what they found. People's reaction time was the shortest here and the longest here, saying that, yeah, our mental images look, imagine you actually had a map and you would use your finger or something, you would get the same results. So this was taken as evidence for mental images being like percepts, like spatial representations, not verbal. Remember, that's the main question. The question is format. And these are the results. So the stuff on x-axis is the distance in centimeters. The stuff on the y-axis is the dependent variable, which is the reaction time or response time in this case in seconds. And as you can see, it's a great correlation, almost completely linear, probably I would say close to 0.9, which is a very strong positive correlation. So the further the distance, the longer the reaction time. Okay, so if you're moving between the well and the hut, it could be 4 seconds. If you're moving between the well and the palm tree, it could be 18 seconds. Again, very well established pattern. It was replicated many, many times with other maps and other designs. So how long does it take? Well, if you scan, right, and you scan at constant rate, interesting, you don't speed up, you don't slow down, you actually preserve the distance. You preserve the spatial layout of the map in your mind, and therefore you depict it. And that's how your reaction time will look like, if it is the case. Another set of experiments comes from what's known as zoom in, zoom out experiments. It's also from various teams that collaborated with Stephen Koslin. Okay. So the idea in those zoom in, zoom out experiments, and I have to tell you, like in the previous one, the words like zoom in, zoom out were not even mentioned. People were doing it spontaneously. So now imagine that you are supposed to only look at the left picture for now. Okay, now again, these are not pictures, these are mental images, so you have to close your eyes. Now I'm asking you to, again, imagine you're having a button box. I'm asking you to zoom in on, so you're looking at the picture, you're imagining the picture on the left. And I'm gonna move it away to here. So elephant and the rabbit. I'm asking you to zoom on something and then imagine that you're going to push the button. So zoom in on the rabbit's tail. Yeah, whatever time it's going to take. Now, let's go back and let's look at the picture on the right. So now you have a rabbit and a fly. Okay, you memorize that. I'm asking you now again to zoom on the rabbit's tail. You're doing it in your mind's eye. So the idea is that in the first condition, when the rabbit is next to the elephant, the rabbit is small and tail is even smaller. You're going to be sort of going down deep and will take you longer. If you're looking at if you're thinking about rabbit's tail in the picture on the right, it's large. So you're not going too far. So the reaction time is going to be longer on the left than on the right. And when people were asked what they were doing, it has to be small details. So you could ask to zoom in, not to zoom in, to imagine the whiskers, although this rabbit doesn't have any, but ears or eyes, something small. And if you ask them to think about a fly, yeah, and that's going to be even longer. All right. again, when people were asked at the debriefing time how they were performing the task, they would say, well, we were zooming in. Okay, so they were themselves reporting this experience of manipulating mental images. And it's very hard to do it in words, if you just think about it. So reaction times, again, these are Koslin's next set of experiments. The reaction times were directly proportional to the amount of zoom required. The further you zoom in, the longer it takes. All right, so again, like I said, Koslin is an excellent speaker. So I have a short activity for you to engage in, and on Blackboard, listen to, I think it's like 6 minutes introduction by Stephen Koslin on imagery and perception. And as always, watch the talk and then write your 200-word summary in your individual blog. Now let's talk a little bit about Polition's work. Like I said, he is a philosopher of science. He's not really an experimental psychologist. Well, somewhat. And he obviously had a few actual encounters with Koslin, but a lot of that was through publications. And the Polition has a couple of famous articles. Again, I'm not suggesting you read any of them because they're quite dense. That's a philosophy of science. What the main point is, what he says is, although it looks like to us that imagery is spatial, doesn't really mean that our underlying representation is spatial. I mean, it's not that easy to kind of comprehend that, but Diamond gave us an interesting way of thinking about it, because she did not find that she was scanning the speedboat the way Leroy did, right? So Diamond would be somebody who goes with sort of Polition's ideas that whatever we're doing with these representations, they don't have to be analog, right? But you know the difference between analog and digital stuff. Now we are in the digital area these days. Think of a regular clock that has, you know, the face and numbers as an analog versus, you know, something that is digital. So in an analog clock, to tell the time, you really have to look for the position of the two hands, the minute and the hour, and then figure out the time. When you have a digital clock, you just say, okay, whatever that is, 11:34. So he says the underlying representation does not have to be analog. An analog would mean that it is like a real object. If you were looking at this speedboat and you would, you know, try to ascertain its components, you'll be looking, like Leroy said, he felt his eyes were moving, right? That's how you would go through this analog motion of space perception. But if it's in your mind, you don't have to be bound by analog. You can imagine, I don't know, has anybody seen Matrix? It's quite an old movie, but it's a good one. Oh, okay, a couple of people did good. How old? It is old. Yeah, but it's interesting. So in a way, or okay, let's, how about Inception? Did anybody see Inception? It's a little more recent. Excellent. Okay, in Inception, I think there is a scene, Jeffrey, I don't know if you remember that, where the sort of the walls of the room sort of kind of fold. I don't know how to describe it. See here, you need imagery as opposed to words. Sort of the room gets warped and you kind of meet, the walls kind of, yeah, meet in between. So one could imagine doing the same. So instead of scanning and zooming, you kind of warp your representation of the map or your representation of the the rabbit and the elephant and the fly, and they sort of, because it's a fictional mind, mental space, it's not physical space, it's not analog, right? If you start thinking about it, might perhaps get a bit clearer. But you understand now what I'm trying to say. It's not physical the way space is physical in our real life. Okay, so if we represent the ideas as nodes and links between them that I showed you in a propositional view, perhaps there is no sort of difference in reaction time, unless, of course, you take the hierarchical structure of semantic networks, which we will talk about in a couple of weeks. Again, Polish's view is not easy to comprehend, but if you start thinking about it, you might appreciate it. Let's put it this way. So his main objection to the results from Kozlin's reaction time experiments is that, well, people report that they scan and zoom because they're used to doing it in the real world. So they kind of take their real world experience with real objects, right, and take that into their mind's life. So they kind of restrict themselves to thinking about space in mental images as analog because that's what they're used to, right? Because this is what happens in real scene. And if we were somehow, and we could use philosophers for that, or Diamond, if we were to use people who can sort of think differently, it's very hard, but one could do that. You could assume these warped connections where the palm tree and the hut sort of meet together in your mental perspective. Then and we do get people who, just like a Diamond, don't seem to have difference in reaction times in such experiments. However, that amount is very, very small. Most people are very analog oriented in terms of space processing. So again, think about that. Okay, our next component is what imagery does to memory. And again, that's not anything new. This is something that we have already done before when we talked about mnemonics as a device that helps encoding. Remember our three-stage approach: encoding, storage, retrieval. You encode information in long-term memory much better if you can bring in imagery. So the method that I talked about, and let's see, yeah, I guess we can quickly do that, was the method of loci, where the word loci is plural from the word locus, which means a location. And for this method to work, we have to have a location with multiple spots that we know well. So this is what I would like you to do, and we will test ourselves on Thursday. What I need is a piece of paper. Okay, so there's 10 of us. So if your mic doesn't work, not a problem, just type in the chat. Let's start with, so what I would like you to do is to come up with an animal, whichever one you want. And I'm just going to call you so that I can write it down. Rebecca, give me an animal. Dog. Okay, good. Leroy. Rat. Okay, good. Karen. Okay. Jeffrey. Tiger. Good. Isaac. Lion. All right. Okay, let's move to the next page. I'm sorry. That's okay. Karen, give me an animal, whichever.
Cat.
Okay, good. Thank you. Okay, next is Jeffrey did that. Diamond. Bunny. Okay, good. Ari. Frog. All right, will do. Parker. Mammoth. Okay. Mammoth. Amr. Monkey. Okay, perfect. All right, one more round. Let's start going back to Rebecca. Rebecca, another one. Squirrel. All right. Leroy. Okay. Leroy.
I'm thinking.
Okay. It doesn't have to be fancy, Leroy. It can be anything, except that it has to be a new one.
Koala.
Koala. Perfect. All right. Karen.
Snake.
Snake. Perfect. Jeffrey. A leafy sea dragon. Oh, come on. Jeffrey, one word. Goldfishes too. Goldfish. Okay. All right, you got me. Isaac. One more. Bear. Uh, who's next after Isaac? Is Diamond. Armadillo. Okay. Perfect. Armadillo. Ari. Sloth. All right. Parker. Rhino. Okay. And Umber. Owl. All right. Okay, guys. Now I want you can either close your eyes or you can stare in the ceiling, whatever you want to do. I want you to now think about your house or your apartment, starting with the front door. You're outside of your front door. You're ready to open it. Mentally walk through your apartment or your house and try to identify a bunch of locations. Well, we technically need 18. I'm not saying that you have to have them all ready right now, but just think, do you think you can get 18 locations in your house or in your apartment? It has to be a place that you know really, really well. Otherwise, it's not going to work. Okay, so now we're going to start with your front door. Okay, imagine, yeah, in the entire house or your apartment, whatever you live in, it has to be something that has some space. If it's just one room, it may not work because we have 18 animals. So imagine you're standing in front of your front door. So you're gonna take the first image, which is first word, which is dog. Now your job is to create an image, right, of the dog that is doing something to the front door. The the more bizarre it is, the better. It can be, hey, it can be pornographic if you want. It can be just unusual. So you need an image of the dog, the way it relates to the door. Okay, I'm going to give you a few seconds. So your job is to create an image of the dog and place it in the relationship to the door. And you need to sort of think about it for a few seconds. Okay, Now you're going to open that door and step into your house or apartment. This has to be another new location, location number 2. Your next object, and therefore image, is a rat. So that location number 2, as you opened the front door and you stepped in, you have to now create a relationship between a rat and that location. Again, the weirder it is, the better. Maybe there is one of those inflatable rats that union people place in front of the stores that don't support union workers. So think about that. So what I'm going to do next is let's see if we can do that. If you run out of locations, that's fine. Let's try to memorize a bunch of these words through different locations. So now we're going to move from the being at the entrance with the front door behind you to the next location where you're going to position cat. Okay, we'll do it a little faster. Doesn't really matter. Your next location is location number 4, where you're going to position tiger. Okay, good. Next is position location number 5, where you're going to drop lion. All right. Okay, next is going to be location number 6. Where you will position a bunny. Okay. Move on to location number 7 and drop a frog there. Position number 8, location number 8, courtesy to Parker, is going to be mammoth. Location number 9 is going to be a monkey. Has anybody run out of locations yet? Perfect. Tell me when it happens to you. We have 18 locations. We are now down to 9. Okay, number 10. Move to location number 10 and imagine your squirrel doing something weird at that location, or something funny. Squirrel in location number 10. Right. Move on to location 11. It's going to be koala. Location number 12 is snake. Imagine some weird looking python doing something weird, or a cobra, whatever your favorite snake is. Moving on to location number 13 is going to be goldfish. Perfect. Location number 14. Drop your bear there. Okay, we have 4 more. Let's see if we can do that. Location number 15 is armadillo. All right. 16. Place your sloth there. Maybe it's the sloth from the ice. What was the name of that cartoon? Ice Age. Yeah, thank you, Damon. Ice Age. All right. It's such a cutie. Okay, so place your sloth in location number 16. Number 17 is rhino. Do something funny with rhino in location number 17. And our final object is owl. That's location number 18. Excellent. Now, try to close your eyes again if you have your eyes open. Go back to standing in front of that front door. And don't look at the chat. Okay. And try to go through the locations. And I'll do it one more time. And then we will come back to that on Thursday. Okay, so location number 1, before you enter the house, your front door is dog. Next location, you open the front door, you're standing with the front door behind you, you have a rat. Location number 3 is a cat. 4, a tiger. 5, a lion. 6, a bunny. 7, a frog. 8, a mammoth. 9, a monkey. 10, a squirrel. 11, a koala. 12, a snake. 13, a goldfish. 14, a bear. 15, armadillo. 16, sloth. 17, rhino. 18, owl. Okay, so hopefully you didn't write anything down because that defeats the whole purpose. That's how imagery hopefully will get some interesting results on Thursday. So please come back and we'll check your method of loci, whether it worked for you or not. We can also do something very cool with auditory imagery. So if you find that exciting, do activity 9.3, which has to do with auditory imagery. So far, I've been talking about visual imagery, but of course, there's nothing precludes us from doing that with other modalities or sensory buffers, right? So auditory is one of them. You have to do a little task and post your results in the blog. Okay, I think we will finish our class today with doing this fun stuff. Perhaps some of you have already learned about it in your Psych 100 class. So let's see what that is. Mental rotation obviously is mental, right? That is some imagery. And what you will probably do with that is rotate it. But again, remember these are subjective reports of participants in this experiment. So this is from 1971. Again, the golden age of cognitive psychology, where Roger Shepard, who was at Stanford, and his graduate student, Jacqueline Metzler, came up with this idea that they would use abstract forms, actually abstract objects, and they will present them to the participants, and they will ask them to compare these two forms. So the task was, if the two forms, and I'll show them in a second, are the same, click this button. If the two shapes are different, click another button. So you get two dependent variables. You get accuracy, whether people answered the question correctly, and the reaction time, how fast they, for the correct trials, and then the incorrect ones are to be repeated. And presumably what people were doing, you'll see in a second, they were rotating these images. So here is, let's look at A first. Okay, so you can see that this is like if you ever done a Rubik's Cube, you're familiar with this, so little snakes. So you have a toy that looks like little cubes. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. And it has this toy, if it's like this, you can then create two angles. So they, of course, did it on paper. And so they showed participants this first item. What do you think, guys? Are the two images in A, are the two objects the same or different? Let me see. Same. Yes, perfect, Hummer. Yes, they are same. How about B? Mm-hmm. Okay, what about C? Mm-hmm. Okay, good. So Leroy and Elmer, because you are the two people who responded, do you have the subjective experience that you were rotating these objects, trying to sort of line them up? Okay, perfect. That was the whole idea. And these are the actual materials from Metzler and Shepard, Shepard and Metzler. That's the way it should be done. Okay, let's just do a little demo. Without showing you the results. So let me give you a different. So get ready with a notebook or file, Google Docs, if you have that. Doesn't matter. You're not going to show it to me. It's just for you. I need to give you a different file. Okay, there it is. Yeah. Okay. So what I'm asking you to do is, in your notebook, number the lines from 1. Oops, you can't see it. I'm sorry. All right. Let's do it again. Gee, why? Your screen sharing is paused. Why is it paused? Okay, give me a second. Meanwhile, number your the notebook, in your notebook, 20 lines from 1 to 20. Yes. While I'm opening, and we can quickly do that. All we need is 5 minutes. Okay. All right. Share. Let's do it now. Share. Doesn't want to. Your screen sharing is paused. 1 second. How about now? Oh, okay, good, perfect. Can you guys see the mental rotation screen? Yes, beautiful. All right, so I'm gonna quickly show you the instructions. You already know what they are, but just to make sure, you're gonna see these 3D block shapes. There will be one on the left, one on the right. They will be within the circles. They're either the same or different. So, and they will be rotated at different 7 degrees of rotation from 0 to 120. Your job is for each of the 20 slides that we will, because we have to do it very quickly, you have to say either same, so write S, or different, write Z, okay? And then we'll discuss the results on Thursday. Okay, this is just a preview that you already saw. Okay, let's start. So remember, 20 trials, you have to quickly do that by writing either same if they're the same or different if they're different. This one is a little fuzzy, but then it will become better. Then ignore the keys because we're not doing that. So write either same or S or different. Next. Next. Four. Five. Six. Seven. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. And the last one, 20. Okay, that's it. The class is over. I'll see you guys on Thursday. If you have questions, email me. You're welcome, Karen. You too, Diamond. Feel better.
Professor, you're able to look at the implications part for mine, right?
Well, I'm going to look at your stuff, Isaac, and I will email you once I read it, okay?
All right. Thank
Have
you.
a good day.
You too, Leroy.
Good day.